Last year, Anker surprised many when they announced their 3D printer brand AnkerMake and launched a Kickstarter campaign for their M5 3D printer. The M5 is an i3 style 3D printer with a fairly clean futuristic look, advertised as being a very fast printer with some fairly unique features like built-in AI failure detection and remote monitoring. For anyone not familiar, Anker, the company behind AnkerMake, is a fairly large company that's been around since 2011, and they primarily specialize in making high-quality chargers and power banks. Maybe it was the features of the printer or the company behind it, but they ended up going on to raise $8.8 million from that Kickstarter, making it the largest 3D printing Kickstarter to date. Well, it's been over a year since the launch of that Kickstarter, all of the backers' printers have been fulfilled, and the M5 is available. AnkerMake sent over the M5 3 months ago for testing, and today we are going to be diving into this printer. In this video, we'll go over the printer's specs, what setup was like, how it has performed, and I will share my final thoughts based on my time with it so far. So, with all that being said, and without further ado, let's get right into today's video. Thank you to VOXELPLA for sponsoring today's video. VOXELPLA is aiming to make 3D printing more accessible with a reliable and affordable filament. This filament has been used exclusively in a 150 machine print farm and is now available for purchase. They currently offer their PLA Plus in black, white, gray, red, and blue, with additional colors coming next year. My personal favorites are Fire Truck Red and Cool White. VOXELPLA is priced at $16.99 per kilogram, and at 2 spools, shipping is free within the US. Bulk discounts for 10 or more spools are also offered, and there is a dedicated forum available for this. Links will be in the description to voxelpla.com so that you can find out more or pick up your own. Starting with the specs, the AnkerMake M5 is an i3 style 3D printer with a build volume of 235 by 235 by 250 millimeters. Weighing in at 27.8 pounds or 12.6 kilograms, this is one of the heaviest i3s I've seen for its size, which is due to its very rigid frame. The frame is largely a single piece of die-cast aluminum with 2 large aluminum pieces that contain the Z-axis. Compared to the vast majority of i3 printers that use just generic extrusions, this definitely gives it a premium feel. For motion, both the X and Y axis are using roller wheels, with the Z-axis using some form of a bushing. I really would have preferred either linear rails or rods for at least the X and Y. The M5 is a 24-volt system with a fairly standard PCB-style heated bed that is rigid mounted to a metal frame. The build surface is a magnetic powder-coated PEI bed with an included second sheet. Inside the toolhead, you'll find the direct drive extruder, PTFE-lined hot end, and 3 fans. The extruder really reminds me of something like a beefed-up Titan Aero, and the hot end does have a fairly long melt zone. It's not quite a volcano, but a fair bit longer than a standard V6. It has dual part cooling fans and a blower fan for cooling the heatsink. Leveling is done using the nozzle and what AnkerMake calls a pressure sensor, which I believe is a strain gauge on the back of the toolhead. On the left side of the X-axis, there is a housing containing status LEDs and a filament runout sensor. On the right, there is a 4.3-inch touchscreen that can be used to interface with the printer. This might be the first time I've seen a screen mounted to the X-axis, but I really don't mind it. The stranger choice to me that I'm less of a fan of is for printing off of a flash drive, it uses USB-C. As much as I'm a fan of USB-C cables, it's definitely a strange placement being on the very top of the screen, and I don't personally think that USB-C flash drives are something that's a standard yet. The right side also has a camera that is used for remote monitoring, time lapses, and the AI functions. The camera quality is plenty good for monitoring prints, but it will not be replacing a dedicated camera for high quality time lapses. The Y-axis is driven by 2 belts and a single beefy motor that has a shaft and pulley on either side of it. The Z-axis has 2 separate motors with independent drivers, which does allow for tramming of the X-axis to the bed. The filament mount is a simple piece of aluminum with a long post sticking off of it that can be mounted on the top or the side. As far as wiring goes, this might be the cleanest wiring I've ever seen, and that's because all of the wiring pretty much goes through just a couple of USB-C cables. I did crack open the bottom of the M5 to see what the electronics look like. The only things down there are 2 Z motors, a 24-volt 350-watt power supply, and the controller with a small cooling fan. The board looks fairly custom, and I was surprised to see 7 or so ports not being used, which makes me think that they may be used for future add-ons like the multi-material V6 color engine that's hopefully being released in a couple of months.
The printer came packaged really nicely in a colorful retail box, which is definitely not the norm, and the setup was super simple. For most, from the time you get this out of the box until you're ready to power it on, it really shouldn't be more than 15 minutes. On the first boot, the touchscreen will walk you through the setup process. This has you set the language and then download the AnkerMake app on your phone to put the printer on your network and connect to the cloud. You can opt to skip this on the printer, but then you lose a lot of the functionality and all of the wireless connectivity. Pairing the printer to the app is simple, and the app will detect it over Bluetooth, which is how it initially pairs. A pin displays on the printer, and you use that to confirm the pairing and then set the Wi-Fi credentials for the printer. Next, it does a 49-point mesh of the bed. This does take a while, at close to 10 minutes, but due to the bed being rigid mounted, this isn't something you'll need to redo very often. Once the leveling completes, you are ready to print. Because it levels with the nozzle, it starts at a 0 Z offset, which actually ends up being pretty close to correct. You'll need to adjust it, but I found that 0.07 to 0.1 was plenty, and I just recommend baby stepping the Z offset on your first print. After setup, I loaded some gray VOXELPLA and began printing a few of the sliced files included on the printer. Each print starts off with a bed jamming sequence, which seems a bit unnecessary, but it's fairly minor to help with a consistent first layer. I had heard that this was a very loud printer prior, but it wasn't until that first layer completed where I got to hear it all kick in full force and see just how loud it is for myself. This printer is up there competing for one of the loudest 3D printers that I've tested. It doesn't bug me, and as printers are pushing speeds, they're definitely getting louder again, but if you're sensitive to noise, this probably isn't going to be the printer for you. Running through the test prints, the results were fairly consistent, and one of the larger tool organizers gave me a pretty good idea of how well that 7x7 mesh worked. It wasn't perfect, but for a thin PCB bed heater, it was definitely above average, and I had zero adhesion issues. The M5 advertises being a fast printer, and it really does boogie. However, this isn't without some compromise. Although I had no major failures with this printer, I wouldn't say that the print quality I was getting was phenomenal. It was good, but I noticed occasional wall artifacts, which I believe was due to the machine being just pushed beyond its limits. Once I completed a few of the test prints, I downloaded the AnkerMake Slicer, which is a fork of Cura. The slicer is functional, and someone new to 3D printing would likely have everything needed, but I really was not crazy about it. In AnkerMake's defense, I just prefer Prusa Slicer or Orca Slicer over Cura. The good news is that you aren't locked into this slicer. There's both a profile in Prusa Slicer and Orca Slicer. The AnkerMake Slicer is needed if you want to wirelessly send files to the printer, monitor jobs, and run the AI, so I sliced in Orca and primarily used the AnkerMake Slicer for getting the files printed. The caveat to this is that there was an update a couple of months ago that lets you bump the acceleration to 5K. However, this is done through the slicer at the point of slicing, so if you want to push those new speeds, you'll need to slice in the AnkerMake Slicer, at least for now. This could be done on a firmware level through an update, and since this printer is running Marlin, if you really wanted to, you could play around with the firmware in VS Code yourself. I understand the need for speed, and it's certainly the direction that it seems like everybody is going, but I do think that a couple of profiles that focus a bit more on a little bit slower speeds and higher quality would be a great addition. The rigidity of this printer with its toolhead can print really nice prints, and it just needs a bit of profile optimization. I did enjoy using the app a lot more than I thought I would. It works great for monitoring your printer and giving notifications when a job completes or if something triggered the failure detection. It's snappy, gives you the ability to do things like preheat the printer, and although small, there is a library of pre-sliced files that you can browse and one-click print. Moving on to the AI, the M5 has failure detection that can be turned on or off through the AnkerMake app. This uses the camera to detect first layer adhesion issues, spaghetti filament mess, and a clogged nozzle. When enabled after each of the first 6 layers, the printer lifts up quickly so that the camera can compare images to the sliced file. It also compares to the previous layer, and if there is an issue, it will pause and notify you. You're then able to confirm and cancel or continue the print. I tested out the first layer detection by dislodging and removing a print, which it detected very quickly. The only issue is that when it lifts very quickly at the end of those first 6 layers, it creates a string, which is a really small deal if you're printing something large, but if you're printing something small or something like a print in place, then it can definitely be problematic. The spaghetti detection just runs for the entire print looking for bunched up filament. I tried this out a couple of times and found one limitation, which is for small prints. This is primarily due to the size of the toolhead housing and the location of the camera. For small prints that don't travel out of the center, the camera isn't able to get a good shot of the spaghetti mess. For larger prints, it had no issue detecting and did a fairly consistent job. I tried the nozzle clog a couple of times by pulling the filament from the toolhead mid-print, and I couldn't get it to trigger. I'm thinking that it might still be in development, as I know they've updated the AI during the time that I've had this printer. With how consistent the first layer adhesion has been on this printer, I wish there was a way to enable certain AI functionality. For me, what I would do is turn off the first layer check so that way it doesn't create those strings, but I'd leave on the spaghetti detective because it's just cheap insurance. Currently, the M5 is just a single extrusion 3D printer, but their V6 or multi-color 3D printer add-on is supposed to be releasing in a couple of months based on their latest blog post. Since it technically doesn't exist yet, I don't want to dive too heavily into it, but it's supposed to allow you to print with up to 6 colors and offer some filament management features. When this does become available, I am hoping to get one in for testing, and I'll definitely update at that point based on what my experience has been like. So what are my thoughts on the AnkerMake M5 after these past few months? Overall, the experience with the M5 has been a fairly positive one, but there's definitely some room for improvements. For the things that I like, the M5 is incredibly well built and it is super rigid. It can also print fast, and other than my Voron Switchwire or my RatRig V Minion, this is the fastest out-of-box i3 printer that I've tested to date. It also provides a nice user experience, especially for someone new to 3D printing, through its screen, app, and calibration. The fact that it's built on Marlin and the slicer on Cura means that community improvements are also possible. Lastly, there is a full library of maintenance and troubleshooting videos, which is something that I wish more companies had. For the things that I'm not crazy about or that need improvement, the first thing I'm going to touch on again is that noise. I mentioned that it's not a big deal to me, and I do stand by that, but I feel like I might be more of the exception and not the rule. This printer is really loud, making it more of a garage or shop printer. This is something that can be improved upon if they go with beefier fans or maybe even higher quality fans, but as of now, it's a loud printer. Next is the roller wheels. I know there's a lot of mixed feelings about this, but personally, I'm just not a fan. They work, which is why just about every budget 3D printer out there uses them, and they're quiet, although in this situation, I can assure you that the noise was not the consideration for going with those wheels. If they're tensioned too tightly, they can wear out pretty quickly, which ends up leading to slop or wiggle in any of your axes, and that translates into your part. And for someone that's new to 3D printing, there's already so many things to possibly check, and it's just another possible thing that could go wrong or could affect your print's part quality. Next is the non-all-metal or PTFE lined hot end, which is a decision I just don't understand. All-metal hot ends have gotten really good and they're very affordable, so the decision to go with one that is going to be limiting the materials you can print with and be degrading over time, causing another point of issues, just doesn't seem like the choice that I would have made. With the speeds that this printer is pushing, you're also going to be printing on the higher side of each filament. So if you're printing with something like PETG and you're printing on the north side of its temperature, you're going to be degrading the PTFE lining in your hot end even quicker. They do include a spare hot end, but that's not really the point. I also heard some chatter about the possibility of an all-metal upgrade, but when I asked them directly, the answer I got definitely was not definitive. Last but certainly not least is the price. As of the time of recording this video, the AnkerMake M5 is $799, although there is a $100 coupon on their website, bringing it down to $699. In my opinion, that's just not nearly competitive enough given the current landscape of desktop 3D printing. If this was 2 years ago, this might be a completely different conversation. The reality is that at $699, there is just a lot of other 3D printer options out there, allowing you to get things like a Core XY motion system, an all-metal hot end, and linear rods. The AnkerMake M5 is a good 3D printer, but it falls short in a few areas. I am really curious to see how their V6 multicolor engine ends up working. One of the claims is no purge tower, and if they found a method or way of doing that reliably, come out with an all-metal upgrade, and figure out a way to lower the price point, I think that they will have much more of a contender. But that's a lot of ifs, and only time will tell. Hopefully we'll know in September, which is when they are supposed to be shipping out the first of those V6 color engine units. And that has been the AnkerMake M5 printer. I hope that you enjoyed this video and that I was able to answer the majority of your questions. If you do have any additional questions, let me know in the comments down below and I will do my best to answer. As always, if I don't know the answer to your questions, I have no problem reaching out directly to the manufacturer to try to get those answered for you. Also, let me know in the comments down below, what are your thoughts on this printer? I'd love to hear them, and if you have used this printer, definitely let me know what your experience has been like below. On that note, don't forget to like and subscribe for more great videos. We make a video every single week, so there's always fresh content coming your way. And if you do want to support the channel furthermore, I'll have links down below in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot, and I look forward to seeing you guys in my next video. Peace, guys!